Welcome to CS 120, Programming 1. Today we will be discussing the flow of control, specifically focusing on the branching mechanism. Outline. In this session, we will cover several types of branching statements: the simple if, the if-else, the if-else-if-else or multi-way branching, and the switch statement. We will also look at how to use block statements and nested if statements to handle more complex logic. Branching statements. Branching statements allow us to execute a specific statement or block of code only when a certain condition exists. This flow is controlled by a Boolean expression, which results in a value of either true or false. The main types we will study are simple if, if-else, multi-way if-else, nested if-else, and the switch statement. Simple if statement. The simplest form is the if statement. If the Boolean expression evaluates to true, the block statement is executed. If it is false, the code is simply skipped. For example, if we ask a user for a negative number but they enter a positive one, we can use an if statement to detect this, print a warning, and then multiply the value by -1 to correct it. Control flow of if. This flowchart visualizes the simple if logic. The program reaches a decision point. If the condition x greater than 0 is true, it follows the branch to print the message and modify x. If the condition is false, it bypasses those steps entirely and continues with the remainder of the program. If-else statement. We use an if-else statement when we need to perform an alternative action if the condition is false. The structure includes a then block for true results and an else block for false results. Only one of these two blocks will ever be executed during a single run. If-else example. Consider this example where we compare two numbers, n1 and n2. If n1 is greater, the first message prints. Otherwise, the second message prints. Think about this. What would be printed if n1 and n2 are equal? Since n1 n2 would be false, it would trigger the else block. If-else statement. The if-else statement is used for multi-way branching. It allows the program to choose one single block to execute from several possible options. The conditions are evaluated from top to bottom. As soon as one is found to be true, its block is executed, and the rest are ignored. Multi-way if-else example. A classic example of multi-way branching is assigning grades based on a score. We check if the score is 85 or higher for an A, then 75 for a B, and so on. If none of the conditions are met, the final else block acts as a catch-all, in this case assigning a grade of N. The switch statement. The switch statement is Java's other multi-way branching tool. It uses a controlling expression which must be a character, integer, short, or byte to decide which branch to execute. This is often cleaner than a long chain of if-else statements when comparing a single variable against many constant values. Switch statement labels. Each branch in a switch starts with the keyword case, followed by a constant label. These labels must be the same type as the controlling expression and can only appear once. You can follow the statements in a branch with a break to exit the switch immediately. The default section. A default section can be included to handle cases where no match is found. Even if you think you have covered all possibilities, it is good practice to include a default section to catch errors. Without it, if no match is found, no action is taken at all. The importance of break. Crucially, a switch statement only ends when it hits a break or the end of the block. If you omit the break, the program will fall through and execute the code for the next case automatically. The compiler won't warn you about this, so you must be careful. Switch structure. Here is the general syntax. The controlling expression is evaluated once, then compared against each case label. Once a match is found, the sequence of statements runs until a break is encountered. Switch example and fall through. In this calculator example, if the user enters 2, the program subtracts the values. Notice that if the break for case 2 was omitted, entering 2 would result in both the subtraction and the multiplication results being printed. Always check your break statements. Block statement. A block statement or compound statement is a group of statements enclosed in braces. It is treated as a single unit by the compiler. We use these to group multiple actions that should all occur under a single if or else condition. Braces and branching. While braces are optional for a single statement, they are mandatory if the then or else block contains more than one line. As shown in the error example, failing to use braces when needed will lead to logical errors where statements run when they aren't supposed to. Nested if statement. You can place an if statement inside another. This is called nesting. The inner if only executes if the outer if is true. For instance, you might check if a salary is high enough for a loan, and then use a nested if to check employment length to determine the specific loan amount. Nesting visibility. Good indentation is vital for readability in nested statements. Both code snippets shown here are functionally equivalent, but the version with explicit braces makes it much clearer that the second if is entirely dependent on the first condition being true. The dangling else problem. In Java, an else always associates with the closest preceding if that doesn't have an else, unless braces are used to change that. Without braces, the goodbye message here would only print if x less than y is true, but x less than z is false. Logic mapping. Let's practice converting logic into code. This diagram shows a complex set of conditions for determining pH levels. By nesting if-else statements, we can accurately categorize a substance as very acidic, neutral, alkaline, or very alkaline. Exercises Part 1. Now it's your turn. Try writing a program to test if a number is odd or even using the modulo operator. Then, try a more challenging task. Read 3 integers and print them in increasing order. This will require multiple comparisons. Exercises Part 2. Finally, write a program that takes a number between 0 and 10 and prints the word for that number. For example, 7 should output 7. This is a perfect opportunity to practice using a switch statement. Conclusion. That concludes our look at branching mechanisms. Mastering these control flows is essential for creating dynamic and responsive programs. Happy coding!